Codominance. Codominant inheritance is when an organism receives a recessive and a dominant allele or is a heterozygous individual. Rather than the dominant gene being completely dominant over the recessive gene, they both appear in the organism. An example of this would be cows. A homozygous dominant organism could be a white cow, and the homozygous recessive organism would be a red cow, and the heterozygous organism would be a roan cow or a cow that is red and white spotted.
In cows, white hairs and red hairs can both show up to form a roan pattern. Number 8. Make a key for the alleles of white hair, red hair, and roan. So white hair is an example of a homozygous dominant individual, so they would be capital R, capital R. Red-haired cows are homozygous recessive individuals, so they are lowercase r, lowercase r. And roan-haired cows are heterozygous individuals, or capital R, lowercase r. Moving on, number 9. If a roan sow or mother and a roan bull or father mated, which percentage of their offspring would be white? So to solve this problem, we would use a Punnett square, and since both parents are roan, or capital R, lowercase r, we can fill that out in our outside of our Punnett square. Working through our Punnett square, we get capital R, capital R, capital R, lowercase r, capital R, lowercase r, and lowercase r, lowercase r. And what percentage of their offspring would be white? And looking at our genotype, we see that white hair is capital R, and referring back to our Punnett square, we see one of the 4 children is capital R. So you get 1/4 or 25%. Number 10. If a roan sow gave birth to a roan calf, what are the possible phenotypes of the bull or father? So we know that the roan sow has the genotype of capital R, lowercase r, and we can fill that out for our 3 Punnett squares. The reason why we have 3 Punnett squares for this problem is because we need to find the phenotype of the bull that could possibly give birth to a roan calf. So we can fill out the white possibility, the possibility of the cow being white, possibility of the bull being red, or the possibility of the bull being roan. And when we work through this with the white cow, we see that it has a 50% chance of giving birth to a white cow and a 50% chance of giving birth to a roan cow. So we can say white is one option. With moving on to the red bull, we see that one option is also a roan cow, so we don't even need to finish our Punnett square. So we see that red is possible. And finally, we move on to the roan bull. So first one, we get capital R, or white. And then the next one, we also get a roan cattle, or calf. So with that in mind, we can say that the father can be a white, red, or roan cow, so it could be anything. Number 11, if you would like to obtain 100% roan calves, what would the parents' genotypes need to be? So for 100% roan calves, to solve that with a Punnett square, we have to figure out that all of these are R, or capital R, lowercase r. That means that one parent is passing down the capital R all of the time, and one parent is passing down the lowercase r all of the time. So the parents' genotypes would need to be white and red. So capital R, lowercase r, lowercase r. So the parents' genotypes would need to be capital R, and lowercase r, lowercase r. The roan pattern in cattle is an example of codominance. Describe the appearance that a baby calf would be if the red and white hairs were incompletely dominant instead of codominant. If it was incompletely dominant, the baby calf would be a mix of red and white or pink. So the baby calf would be pink-haired.